Moraes. As you can see by my t-shirt, I work for HP. I'm the product manager across Europe, Middle East, and Africa. And I'm working on we call it business critical systems. It's a division that typically works on big projects, consolidation, business intelligence, and the app system for Microsoft Parallel Data Warehouse is inside of this decision. And it's been a fantastic days when we launched the appliance. So we launched the appliance in mid-April. We start shipping the first units end of May, beginning of June. So it's quite new. Although the product is the second version, so we are on version 2. We were not seeing the same results in terms of performance than we are seeing in the second version. There are quite a number of differences. I will try to go to them. So yeah, let's start. I will explain a little bit why does the market need these kind of solutions, who are the typical customers. We are building the hardware to run the PTW software, and some customer examples in terms of some benchmarks that we just did recently. So we will see the performance that you can get. Okay, let's go. So this is all about big data. And Gartner defined big data as a combination of those three attributes. So you need to have a lot of volume of data to be analyzed. You need to be fast, and you need to be able to cope with lots of types of data. So in the past, we were just using, in the past, and I think most of the customers in our days are only working with transactional data, so OLTP data. And there are new type of data types that are now being considered for the business. And probably if you didn't have a request from your management to look for big data or for unstructured data, is because or they didn't realize how much they can benefit from having this type of data considered when they take decisions. So we had this week in Prague an event with our major customers in HP. Microsoft was there with us, and every time we present the solution, the reaction is always the same. Wow, I didn't know you could do this. So it's really kind of new. It's not a solution for all the accounts, so we need to have a certain number of volume, a certain number of needs. But if you are on that context, you can really benefit from the speed and the costs. Really very price for value. So yeah, the world of IT has been changing lately, and customers want to react faster than they used. So in the past, the business intelligence, the BI solutions were mainly looking to the past. So what were the best sales in the last week, last months, who were the best customers, but always looking to what happened in the next days, months, or years. So now the challenge is a telco, for instance, that launch a new product, a new plan for their customers, and can look for Twitter, can look for Facebook, can look for other type of social media applications, and in real time can take decisions on what the population is mentioning or comment on that new product. So, and is kind of changing the behavior, changing the business that the customers are used to do. So also another example is looking for weather conditions and how that can affect a complete fleet of trucks or taxi drivers to save money, basically. So that's something, another example. And for fraud detection in banks, where they can really correlate information, customer behaviors, to protect the transactions. So there are new forms of doing business, and that's where PTW can really help customers. And these are the examples of the types of data that we have basically in our customers. Typically, customers tend to spend lots of time on structured data when we create really robust solutions around backup, disaster recovery, well protection, and having a solution really fast. So these are the transactional type of workloads where we are working for 20, 30 more years. Then we have the kind of SME structure, Excel, that you normally just store it, don't do nothing with that information. But there is some value there that you need to be able to extract. And the unstructured data, which is email, texting, SMS, audio, video, blogs, the Facebooks and Twitters. Images are now being, for instance, we have stores that are now considering to have some kind of imaging detection, and they can relate the face of the customer that is entering in the store with their buying behavior, and can in real time create some promotions in real time. That's something new that is happening. So we are working on that. But that represents 90% of the volume that we are having today. Because a video can easily go to gigs, while the structured data is not big volume. So need to be considering this also. An example of structured data and non-structured data. So you see from your left a list, so basically a file with name, title, company, and a business unit. This can be anything. It can be a list of people that are going to have a meeting. It can be a list of customers that are going to dinner out. It can be a list of customers that are going to catch a plane. We don't know. We need an application, or at least a context, to get some value out of this information. We don't know what that is. But if you look for your left, can be an email or a sheet of information where you can read it and you can really extract information immediately. So this type of unstructured data is ready for the human brain, and this type of data is ready for the computer brain. You can call it brain, okay? Computing processing power. So if we can combine these two worlds, we can really take better decisions. That's the challenge with PDW, okay? And if you can see that the transactional, the structured data has been in our IT world for a while. It's not going to have a huge growth in the next years. It's not ready to deal with unstructured data. Or if you might consider using structured data for unstructured data types, you'll be ending spending lots of money on licenses. So we need to consider Hadoop, PDW, other types of applications. And it's going to grow exponentially in the next years. So you can see by the room, you don't see too many people today, but next year, when this is becoming more popular, we'll see probably more people interested in this. We're just getting the first steps here. But it's going to grow. And everybody's saying the same. So IDC is saying that to get in the year of 2010, the humanity was able to store digital content in the size of 2.8 zettabytes. And in the next 10 years, or in 2020, we will have 14 zettabytes of data digitally stored. And you can see it why. In each minute of our world, lots of Twitters, lots of Facebook comments, and there is some nice, I'm not sure if you can read it. So in 2000, to view all video crossing IP networks each second, in 2015, you will need 5 years. So everyone is using more digital content. So that's why we need to define the next IT world to deal with this new type of unstructured data. Now, kind of set the scene why we are needing this type of new solutions. I just thought maybe for your interest to know what is a zettabyte, so the dimension where we are. So we are already considering the next two, let's say, waves of volume. So we are going to yottabyte after zettabyte and brontobyte after yottabyte. So just some naming that you might get to get. IDC is saying that it will be faster to get to those volumes than we think. Okay, so if you consider a day in the life of IT, so you know this better than me for sure, we need to deal with volume from all those transactions, the way we communicate with customers, partners, suppliers, our employees. So all these applications are generating data. We are now seeing mobility and customers having mobile devices with the same information that they have in data center. So we need to deal with that context also. But there are other forms of data that are kind of being introduced in the data center world, not only in our personal life, but also in the customer decisions. And velocity. So this is what Gartner defined as what is big data: variety, velocity, and volume. We in HP, we are working on this concept, and we add another V, which is value. So he's combining all these elements and create value to the customers, create better executive dashboards, better enterprise search to look for new opportunities, new markets, products with more margin. So those concepts are coming to the reality of our customers. Better customer interaction. So we know that the customer in a website, you have seconds to promote new products, and we are seeing more and more of that. So you need to be fast. Predictive analysis is something that is coming very fast to the market. Be able to predict the next wave of products that will fit in the market, new campaigns that will better fit the customers, and better web engagement. So we need to make sure that all those 3 V's can get the 4 V, which is value for the customer. So that's why we are building solutions for big data. And we have several. We are going to touch PDW today. Okay, just coming back. I mentioned this before, but just let you know that we start in the 60s with mainframes, hierarchy data models, then we move to relational data models, okay? You know them all, Oracle, DB2, Sybase, SQL, Informix. And now we are going to the new wave, which is Hadoop, okay? To deal with unstructured data, okay? And what is PDW doing is combine these 2 worlds. And the need for this combination is arriving to us because dealing with the unstructured data or big data and using what we call the legacy models, SMP servers, or the scale-up servers, as we want to mention, we will find a limit some way, or is in the number of CPUs, I/O, memory. So in some way, we'll find limits on the servers that are in the market today. We are finding some players in the market creating some specific appliances just for big data, but they are proprietary and high costly solutions, so I'll not avoid you to go in that direction. Investing a lot of your time on training just for Hadoop probably is not the best investment. And creating new ways of new applications just for business intelligence is not bring you the solution, and is going to basically create a new island on your already complex environment. So there are other ways of doing it. So if you know already, if you have any contact with Microsoft PDW, you know that there is this concept, this tool inside a product called Polybase. Polybase is the ability to using SQL commands, searching the same way structured data and unstructured data. There is a translation in the product, but you can have the same SQL language querying Hadoop file system. So you don't need to be trained on Hadoop file system to be able to extract information from an Hadoop. the PDW will do that for you. And just mention what we are doing together with Microsoft. So HP and Microsoft are working in the SQL world for a while now. And there are things that are coming from, the majority of products are coming from Microsoft, but the way we can scale or the way we can perform in the hardware are really coming from our labs. If you know SQL 2012, and it can scale up to 320 virtual CPUs or CPUs if you are working with a physical server, that is coming from HP. So we are bringing our experience from the Unix world that is scaling already on that scale, and we are bringing those engineers working with Microsoft to scale the operating system and to scale the SQL to those levels. So there has been a really interesting conversation between the two engineering teams to bring those new features to you, and it's been really interesting. We just released last November, in one of our servers. Is a 8-socket server. It's not. We call it the ProLiant DL980. You can today recover from memory errors. So in the past, with the SQL 2008 and Windows Server 2008, if you have a problem in the memory, the server will reboot immediately. Now, if you have a problem in the memory, even the operating system or the SQL engine will recognize the error, will send you an alert, but it's not going to reboot. So we are getting better solutions together. So it's really a work in progress, but we are kind of seeing the results. We have this infrastructure to apps kind of joint venture. It's an agreement for the next 3 years. We just renewed the contract, where we are going to invest $7 million on two initiatives. One is private cloud, and the other is mission-critical SQL proposal, basically. So improving those solutions. And we have executive sponsor across the world, also EMEA, to really make sure that every single customer can benefit from those investments. Okay. So let's go into the details on the technical level. So as you know, HP, we have designed, or we have come to this concept of the HP converged infrastructure. Because in our portfolio, we have servers, we have storage, we have network, when you bought 3Com, security software, management tools across all these elements and services. So in terms of what is the infrastructure, we are the best player in the market to be able to design those solutions. And Microsoft is building the software. Okay? And we are combining these two huge companies to design what is the app systems for PDW. Solution for business intelligence, of course. This is not for LTP. So, just mentioning that before we enter into the details, there are several ways of building a solution. You can build it using your own knowledge, so you're using your own engineers in your company, and by that you will have a solution that will fit your application, but is unique. It's only for your application. So we call it that a kind of a test or cooking your own food, more or less. Then you have what we call reference architectures, where we kind of design the solution. It's something that several customers can benefit. It's well documented. You know the elements that you need to buy, and you know the performance that you will get. So we call that a kind of a recipe for the solution. And then we have the complete integrated solutions. That's where the app systems fit, which is something that we design with Microsoft. We build using our best portfolio. We install and ship. So basically, you will get a solution like this one, which is quite complex, but you will get it in your data center as if it was a laptop, completely installed and ready for production. So a cook ready to be enjoyed. So this is what we call the way we build app systems for Microsoft Parallel Data Warehouse. So you're not buying a car like this, you are more getting a car ready for run. So basically, this is the concept. So we are not doing this on our own. So as soon as the factory gets the order, we immediately go in contact you. So we will call you or we'll send you an email. Mostly your regional or local contact will send you this form where you are going to send us all the IPs, all the license of that you have bought from Microsoft, the name of the nodes, you will see it later, what is your power connections, well, lots of information that then our engineers in our factory in Europe, which is in Czech Republic, will build the appliance, but in direct contact with you. You will have a project manager assigned, and we will contact you during the process, so we will kind of control the solution. And by doing this process, you will save lots of time by starting the production. Because if you have to install it on your own, you are exposed to errors, reinstallations, calls, doubts that you have to deal, while our engineers are only doing this, so they become experts on the subject. And if you have a problem during the life cycle of the app system, you also benefit from our experience dealing with the case. So everything will be documented, there is no surprises. So you can see here the number of weeks that we need to send you the solution ready to start in production, meaning loading the data. And we are seeing between, well, six weeks was kind of one of the first orders, and we were so kind of improving the process, but then it comes easily to 3 to 4, and this is what kind of before the release date. Now that we release the product and we are ready to full production, we are seeing 2.9 weeks, 3 weeks, to get the order, put the order together, put all the elements, storage, network, switches, install the software. Okay, we can do that in 3-4 days. It's not that easy. There are lots of things to install. But then we need to test it. And the test can be 3 or 4 days. The app system running in our factory, just to be sure that we will not have any surprises. You see that from the Netherlands, there is a comment from our colleague, Philippe Blondeau. He's from technical services. He received the rack in the customer data center. In 1 day, the customer was ready to start loading data. This is not very common, I think, when we are building those kind of solutions. In 1 day, start the production. And we are seeing this repeatedly all over the country. So I think the process is very well designed. And we are going in this direction with Microsoft. So what is really the appliance? What are we talking about? So we are on the second version, as I told you before. The first version, we didn't add Hyper-V in the nodes. So we were using virtual servers. Now we are using Hyper-V to make it better. The virtualization really helps the failover, the high availability. We have a more condensed rack. Is only using 1 rack, not 2. And we remove the SAN environment. So the storage is not using a virtual array. We are using direct attach storage to the nodes. You will see it better in the next slide. And moving from the previous version to the newest version, we are benefit from several things. Better software. We have X velocity, column store, more compression. So we are seeing 100 times faster on the queries, 30% improvement on the scan, and a much better cost. So the customers are really impressed with the cost of acquisition of a solution like this by removing a SAN that is not necessary. So lots of switches there, another array, so we don't need that, and it's much faster without the SAN. So we will see in detail. Bear with me just a second. We did just, was 2 weeks ago. We had a customer, they were considering our PDW or IBM Netezza for the same business intelligence environment. Okay, the customer asked us to benchmark both solutions. Okay, let's do it. So there was one particular query that was taking 190 seconds on Netezza, and on PDW only 4 seconds. Okay, great result. Then we went to the customer. Okay, that's because it's a big query, lots of data. Let's go to a smaller one. We already need slow response time, but with less data. So let's do it. With us 3 seconds, with Netezza 10 seconds. So this was 2 weeks ago. I was following this very closely. We also did some tests on DB2, on IS400, and we were much faster again. So it's really impressive, and this has been repeated in all over the other customers. So we had another French customer. I cannot tell you the names because I'm not authorized to do it, where they are comparing just PDW, and you know that PDW can work with Hadoop file system, but also with structured data. They were comparing Hadoop against PDW. And on the Hadoop file system, we had 120 nodes, and PDW only 10 nodes, which is what is represented here, 10 nodes. I will explain you how it's built. And the customer was moving from 5 minutes to 1 second, because Hadoop is not that good for structured data, so here is not the best case. I'm not saying that Hadoop is not good, but in this particular case was really a huge improvement on performance. And that was the French comment. If you know French, you know what that means. C'est impossible. So it means it's impossible. So he has to run it again. And we are seeing this in Russia. We are moving from 90 minutes to 49 seconds. Here we are comparing the SQL Server 2008 with the PDW, which is a different version of SQL. So I will explain you later again how we are spreading the data to the nodes. And when we query the main node, the query is spread across all nodes. Each node has a particular subset of the entire database. So you have several nodes answering the same question on that particular subset of data on that particular node. So there is a very parallelization of the query. So really, really fast. I'm not going to all the details, but you can see that we are getting better and better performance comparing with the other solutions. I will let you read the results. Okay. Good. Let's move on. So what are we building? So we start first. Of course, we need to have some kind of assessment, some design. We need to know the number of nodes that your particular case needs, the size of your data warehouse, how many terabytes are you using, and basically that's what we need to know. Then, of course, there are other kinds of assessments on which data you want to bring to the PDW, what are the queries, what are the results, what you really need. Then we will start by building the infrastructure, which means putting the rack together, the nodes, the storage, the switches. I will explain you how it's built, assembling everything together. We will install the Windows Server 2012 with Hyper-V. And then we will install the PDW software. So the PDW software needs to be bought to Microsoft. All the rest can be. So you always need to deal with two companies. So we need to buy the app system from HP and the SQL PDW license to Microsoft. As soon as we get that, we can build the appliance. There is some HP management tools that we provide for free. So basically are tools to make your life easier. So if you want to change the passwords of the nodes, you don't need to go node by node. Just change in the management node, and it will spread that change in all the nodes. If you need to update any patch, just do it once. You don't need to go node by node. If you want to know the health of the system, if all the nodes are working in perfect conditions, if there are disks with problems, if there are any switch that is not communicating well, this management tool will give you the information by one click. And on-site deployment services. On-site deployment services are just making sure that the appliance arrives, is connected to the power, you connect it to your LAN, and is working. So basically, it's a hand-to-hand experience. You can start with one rack, and we call it a quarter of rack, which is that one, the smallest one. Only have 2 nodes. You will see it later. Sorry. So you can see the nodes are here, 1, 2, and 1 storage here. And then you can grow having always 2 nodes and 1 storage. So the granularity is always 2 nodes and 1 storage. You can grow, you can add more racks, so you can have up to 7 racks working together. And you can grow 7 racks means 64 nodes working in parallel, up to 6 petabytes. So you can imagine what the monster that this can grow. But we are seeing our orders that we are getting are basically being 4, 8 nodes. And we are talking about the first projects in customers. So we had a project recently, so was shipped 2 weeks ago. The customer are getting the first results and is going to already upgrade it. So customers, after getting the results, they start pulling more data to the PDW. Yeah, that's what you can get in terms of growing the appliance. Finally, details. So this is a picture of the full rack. This is, let me count them. 1, 2, 3, 4, 6, 7, 1, 2, 3, 4, 6, 8, 9, 10, 12 nodes here. This picture is not correct. You can only grow up to 10 nodes in one rack. 1, 2, 3, 4, 6, 8, 9, 10. So this is wrong picture. The colored elements are the basic configuration, and the basic configuration is made of course, the rack, switches. So you have 4 switches. So 2 switches are Ethernet switches to link to the outside world of the PDW, and the InfiniBand switches to connect all the nodes with each other and to connect the disks to the nodes. This, it will be on a Hyper-V environment, everything completely virtualized. You have the blue nodes, which are the first one for management, to be the quorum, to be the management of the Hyper-V, and the second one will be the failover. You'll see it how it works, but since in this configuration you have 12 nodes, if one of the nodes fail for any particular reason, the failover node will enter the PDW, will assume the workload. So you can have more than one passive node. So if you, depending on the high availability levels that you want to install, we advise the customers to install at least one passive node per rack. That's depends. You can have 2 more, 3, depends. So that's how we build the system. So this, I will go into details on this, what we call the active node elements, which is composed by 2 servers plus 1 storage device. So let's go into that details. Here you have the 2 nodes. The 2 nodes are basically 2 ProLiant DL360s. They have 2 CPUs each with 8 cores and 256 gig per node. As I said before, they are virtualized and they are connected to a storage, which we call it D6000. You have 70 disks on each D6000, but they are split in 2. So 35 disks per node. Okay. You can select 1 terabyte per disk 2 terabyte per disk or 3 terabyte per disk. So depending on the size of your database, if you want to have more nodes or less nodes, so it's very flexible the way we build the appliance. And as I said before, we are talking here direct attach, so really fast response times. The management node and the failover node is another 360, similar to the active nodes. So this is what looks like in terms of the architecture. So the quarter rack is here. You'll see 2 compute nodes, so where the queries are going to be made. Direct connect with the D6000 and the disks, and on top you have the management node, and this node is just sitting there waiting to fail over. So since you have the InfiniBand switches connecting all the nodes, if you get one failure, one node, the other will assume, and using InfiniBand switches, you will be connected here. So no impact for performance. Okay, let's go to capacity. So let me go here, I can see it here. Using 1 terabyte disks, okay, if you are using 2 nodes, we are talking about 15 terabytes of data for the customer, because you need to spare some space for TMTB and for logs. I will go into details on how you build. So using 1 terabyte disks, if you scale up to, in this case, 56 nodes, you can go up to 64. We're talking about 2 terabytes, 2 petabytes of data. 2 petabytes of data using 1 terabyte disks. How you get there is pure math. Don't need to be an expert to understand it. So 2 nodes connecting to 70 disks is the shelf. 35 disks per each node. So you multiply. So basically, I'm telling you 35, but in reality, each node needs 32 disks. So that's the architecture for Microsoft. If you multiply 1 terabyte plus 332 per node, you have 2 nodes. Then you use RAID 1, so divided by 2 again. You are talking about 32 terabytes in total. After you format it, you get 29 terabytes. If you don't exceed 85% of the total storage, and you give some space for logs and MTB, you will get to 15 terabytes. Okay? Non-compressed data. So if you use a 5-to-1 compression rate, it depends on your data, you are talking about 75 terabytes of user data. So when I mentioned 15 terabytes, it's already compressed. Because the compression here is really important. Since we are using columnar store, the compression is really strong. So if you go to 2 terabyte disks, you can grow up to 4 petabytes. If you use 3 terabyte disks, we are on 6 petabytes. It's very, very easy to get there. This is just for a reference, not really big important. I mentioned the support pack utility suite. So in one button, is one software that can really reduce your operational costs and make your maintenance very easy. In one software, in one click, the appliance can really go into all these elements here, switches, see if everything is working in the best conditions. And if you want to upgrade, you will use that software and it will do it for you. So, okay, let me go back, getting to the end. Support. So you buy the appliance, you install your data, and then you want to know how do we deal with support. So we're talking about an appliance between HP and Microsoft. If you have a problem, something's not working well, you call Microsoft. Microsoft will work with you. If we come to a conclusion that is an hardware problem, Microsoft will route the problem to HP, and we together, between HP, Microsoft, and you, of course, the customers, will solve the problem. So that's how it works. But since our nodes, talking about ProLiant DL 360s, they have a mechanism, we call it inside support, that can open calls in our solution center. So if one of those nodes finds an hardware problem in the server and opens a call on our solution center, we will know that is a PDW, and we will call Microsoft, and we will go together. So that's kind of a hand-in-hand approach. We are adding additional support on PDW, like we call it proactive care. So it's not a reactive type of support. So we are making sure that we have semi-annual firmware patch, a visit from an engineer. So an engineer from HP will visit you twice per year, just to make sure that you are on the right level of patch. And you have one per quarter, every 3 months, a visit with a report on the incidents. So we will control with lots of details what's going on with your appliances. This will make the life cycle of the appliance really easy to manage. It's 24/7, and that's the way we are proposing to run the appliance. So this is my last slide. This is the summary. We are building it for high performance, really easy to scale. You can scale just by adding 2 nodes up to 64. And if you compare the cost of the solution per terabyte with other solutions in the market, you'll see a huge surprise, considering that with PDW you can combine structured and unstructured data. So we are very, very pleased with this solution. The customers that we are talking about also are giving this same feedback. It's ready for shipment. It's just a question of contacting your natural sales representative, and we will be able to help you. And with that, I would like to thank you for your time and open to questions if you have any. I cannot hear you.
What about the SQL version?
Yeah.
If you buy this and later when SQL 2014 comes, will
Of course.
they upgrade?
Of course. So we are doing that right now. So this is the version 2. We have the version 1, and we have customers running version 1. And when we release the software, when Microsoft releases the version 2, that version 2 can run on version 1. Just need a small upgrades on the hardware. Just need to change the switches, the InfiniBand switches. That's it. But it runs. When it comes next year, we need to analyze if we need to change anything on the hardware. But it will happen with us again. Next year, Intel will release new CPUs. So the servers also again need to be refreshed. So this is a continued evolution of the upgrade. So I cannot tell you today how it will be when we have a new version of the software or a new version of the hardware. So it's something that is constantly being innovated. So we are working on the upgrade path. So I don't see really a huge problem on that. All the customers are in the same situation, so we make sure that it's easy for you.
But the upgrade, is it you or the customer or together?
Oh, the actual upgrade paths from the version 1 to version 2, we are really under. We don't have too many to upgrade at this moment, but we are working case by case, and the cases that we are making for free for the customers, without having any cost for the customer. Because from release 1.4 to to the version 2.0 was really, let's say, a small space. So we want to kind of protect your investment, and we are not going to charge nothing. But this is, of course, you need to buy the switches, that's it. But then it will be there for a long time. So having the next version, this is not the same version of SQL that you have for a standard server. This is a special version that parallel the queries across several nodes. We call it massive parallel processing, while the standard SQL is just for one server. Of course, you can have always on, but that's a failover mechanism. It's not. So we don't have yet indication from Microsoft when it will come the next version of PDW, because this version was released in April. So we just released the version 2.0. I don't think that in the next year we'll get any new version. Although in SQL standard you will have the next version next year. So, but I think we always consider customer protections investments. So I would not bother with that. There are always new things coming. So, okay. Thank you for the question.